This is a particle podcast. WA Science told different. Powered by SciTech.
Please Look Up is recorded at SciTech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, your monthly deep dive into all things space.
And commentary.
My name is Leon.
And I'm Beth. And in this episode, we're discussing all of the space news.
And everything you can see in the night sky in the month of October.
So, Leon, what's up this month?
What's up this month? This month, there's a little bit of everything for everybody. Is the best way to summarise it.
So, let me guess, we got some stars.
We got some stars.
We got some planets.
Planets.
Satellites.
You can always see satellites.
Always see satellites.
The moon's putting on a good show. There's meteors. There's a little bit of everything.
That's amazing.
Let's start with the stars. This month of October is sort of your last chance to get a good look at the Milky Way.
Oh.
Because Milky Way's best time of year is in July, July, August. And as the month goes by, as the year goes by and the months pass, the Milky Way moves closer and closer to the western horizon at nighttime. And in October, it's the bright part of the Milky Way is kind of just sitting above the western horizon. And then by, the middle of November, it'll be below the horizon.
Right.
At a reasonable time of night we're talking about.
Yeah, of course. As we say pretty much every week, there's people who are up at all different times of night.
Of
so
course.
we're kind of focusing on sort of around like
8,
9 p.m. Like
Yeah.
I could actually feasibly stay up on a school night and see this.
Yes, that's
rather
right.
than
3 in the morning.
the Beth hours of 1 a.m. or the Leon hours now apparently of 5 a.m.
Yeah, I've turned into a monster, I'm afraid.
Betrayed me.
Yes, exactly. So I happened to be out away from Perth just last week, and I was able to see the Milky Way in all of its glory. Obviously, it looks better without light pollution, just sitting there beautifully in the western sky after sunset.
So I was also out away from Perth a few weeks ago, but I was out. Do you remember we were talking last month about the supermoon?
I do remember that.
I was out nearer to the supermoon. So I could see no Milky Way at all, but I tried and I could read by the light of the moon, which was the thing that I was talking about, like whether I could do that when the moon was super bright. And I could, and I read. I could read outside.
Well, there you go. Supermoons, just by the way it turns out, because there's no real sharp definition, if you wanted to, there are some outlets actually calling this month's full moon a supermoon as well.
Oh.
Because it's not like a hard definition.
It's still because it's just because of how close the moon is to Earth at the moment, and it hasn't moved that far away.
Compared to last month, it's done a whole orbit again.
Yes.
But just by the orientation of the orbit, it's almost back at its close point during the full moon again. So some people will say it's another supermoon.
Fair enough.
I don't particularly get into it, but I'm glad to hear you could actually read by the light of the full moon.
Yeah, it was amazing. Sorry, so this month, Milky Way, last chance, unless the moon is out, in which case,
that's right.
Too bad.
Yeah, the moon's out towards the end of the month, so first half of the month.
Get out there and catch that last glimpse of the Milky Way until when is it going to come back?
I mean, it sort of starts getting good again around about, March, April next year.
But like that's a few months without the best bit of the Milky Way.
The best bit, yeah, exactly. It's kind of going to be lost behind the sun. It's never going to be not there. It's just the best part is always during winter. If you don't want to look at the Milky Way, of course, you can, look at the evening star. Venus, that's right.
The liar, not a star at all.
No, that's right. It is dominating the western sky after sunset.
Isn't it also Venus not just this month?
No, that's right. It's because of where Venus is on its orbit, it's kind of chasing after Earth because both planets are moving around the sun in the same direction, but Venus is kind of lagging behind Earth at the moment, but it is moving faster, so it is catching up. And because of the geometry of that, that means it's going to be in the western sky for about another 5 months.
Okay, so if you miss the Milky Way this month, you've missed it. But if you miss Venus this month, don't worry about it.
Next month. It's probably going to be better next month, if we're being honest.
There you go.
But if you can see something bright in the western sky after sunset, it's Venus.
It is Venus.
Yeah.
I love the romance of it being Venus. Venus being the goddess of love, and it being called the evening star. I just think it's all very romantic.
Yeah, it is very romantic.
And just after sunset, if you're out having a lovely walk.
It
with
is.
the love of your life.
It's lovely, isn't it? Until you read, of course, about the actual physical properties of the planet.
Oh, yeah, no. Raining acid?
Yeah.
No, thank you.
400 degrees Celsius on a cool day.
Yeah.
Yeah. Ah, beautiful.
Crushing pressures.
Ah, love it. Failing that, or if you're not impressed by the Milky Way or you don't want to see Venus, there is a meteor shower as well.
Oh.
It's called the Orionids meteor shower.
The Orionids.
Yes. What do you know about the Orionids meteor shower?
So, the Orionids, I know that they're called the Orionids because of where they seem to originate from in our night sky, which is in the constellation of Orion.
Mm-hmm.
But I'm pretty sure that the Orionids are not as easy to see in the southern hemisphere as they are in the northern hemisphere, because Orion is not yet up in the night sky at the right sort of time of night. So we'll see some of the like tail ends of it, like the further out one, the slightly more random ones, whereas the northern hemisphere, the Orionids are one of their like big 2 meteor showers. And I know as well that the Orionids are the meteors are actually made of the dust from Halley's Comet.
Yeah. You couldn't have said any of that. I couldn't have said any of that better myself.
I know about the Orionids.
Yeah.
They're one of the ones I know about.
Yeah, you're right. Yeah, it's not the best time of year for people in the southern hemisphere. You're correct. Orion is very low on the horizon at this time of year and rising at 3 or 4 o'clock in the morning. So you do need to be quite keen to go out and do these to see these ones. Yeah, so the best time to see the Orionids is about 4 o'clock in the morning. You sort of look to the northeast. That's where Orion is at that time of night, and yeah, the shower peaks on about the 20th of October. So that's when you can expect to see the most meteors. Unfortunately, this is just one of those years where the moon is actually going to be quite close and bright to Orion on that night. Now, it doesn't mean you won't see anything. You could also go out and look, maybe a week either side of the 20th, where the moon's in a different part of the sky. So yeah, you're right. The Orionids can be one of the biggest and exciting meteor showers of the year for up north.
Yeah.
Down south, it's a bit less. And this year, it's just the moon's in the way.
Yeah.
It doesn't mean you shouldn't look, but it is.
Well,
there.
especially because, like you say, the 20th, 21st-ish is the peak of the shower.
Yes.
But because it's quite a large meteor shower, it's not like... I think that when people think of meteor showers, they think like, oh, there's going to be 20 minutes on one night where there's lots of shooting stars.
Yeah.
But that's not actually how that really works. It's
No.
like over a series of weeks even, there will be some meteor activity. It's just when people say the specific day and specific time, that's when like the thickest part of the meteor shower is. So that's when you see the most of them.
Yes.
But there'll be some either side. So like you were saying, like, go out the week before, go out the week after. Maybe if you are up late on Halloween,
Yes,
that might be a good time. Maybe you might catch a tail end.
That's not a bad idea. Yes. Yeah, exactly right. And that is a good point to clarify that it is not it's not like a shower like you might have at home.
Yeah, I think that's
droplets
like
of water.
that's the thing that comes to mind is like, it's a meteor shower. There's going to be 20 minutes or 5 minutes of the whole sky covered. It's actually a long period of time, but a smaller part of the sky than you might expect.
Yes, that's right. And that comes back to the sort of physical origin of meteor showers, which we briefly discussed a while ago, but it's worth reiterating that if you think about, you said these meteors came from Halley's Comet.
Yes.
So, some many hundreds of years ago probably, as Halley's Comet orbited around the sun, little bits of dust are constantly falling off the back, and they are left in the wake of Halley's Comet. So Halley's Comet, moved away a long time ago. It's nowhere near us right now. It's not going to present any danger to Earth. But all those bits of dust that are still been left behind, Earth is now ploughing through that dust stream.
Yeah.
And that dust stream is spread out over time. So it takes Earth a few days or weeks even to pass completely through that dust stream.
Yeah, and that's why you get meteor showers that come from the same section of or look like they're coming from the same section of the sky at the same times of year on year. It's because we are back in that part of space. Like, we've come back around again.
Yeah.
Through that dust stream.
That's right. And so that's why it's very easy to predict when a meteor shower will occur.
Yeah.
It's very hard to predict when a meteor will occur.
Yes.
But you can say between these weeks you will see more meteors, and that's because of the meteor shower.
Yeah.
I couldn't tell you to the minute when a meteor will occur.
Well, I imagine also that would explain why we see fewer of them in the southern hemisphere, and like why they look like they're coming from Orion is because of the way that we're plowing through, like, you know, obviously,
Yes.
like if you think about like a car driving through a big puddle, a majority of the car is going to get splashed on the front by the water. You'll still see some around the sides.
Yep.
But most of it is going to be splashed across the front.
Yeah, there's a bit of geometry to it as well.
Yeah.
And as I like to think about meteor showers as the bug on the windscreen.
Yeah,
It's
yeah.
splattered past. Yeah.
Two very different, like same car, two very different attitudes
Different
towards
analogy.
it.
Now, speaking of Orion, a nearby constellation to Orion is this month's Constellation of the Month.
Constellation of the month.
Constellation of the month. Orion.
Are you just going to let me talk about Taurus for ages?
Yeah.
As my weird little special interest constellation that I've got going on.
I think we should. So the constellation of the month this month is Taurus the Bull. Taurus is next to Orion in the sky, and in fact many stories have Orion and Taurus duking it out with each other. We might hear about those from you, Beth.
Yeah.
If you want to see Taurus in the sky, you do have to be up early, 3-4 o'clock in the morning. Because,
Or up late.
Or up late, that's true.
3-4 o'clock in the morning.
Yeah, so it's not the best time of year to look at it, but it's just such an interesting constellation that's why I've chosen to unleash the Beth.
So Leon chose this constellation, and then I said, oh my goodness, is this Taurus? And Leon was like, yeah. And I said, I have 3 pages of notes already about Taurus.
These were just lying around.
Just
Beth
lying
didn't
around,
prepare these for the
genuinely.
podcast.
This is just in me being a normal planetarium presenter. I have 3 pages of notes on just Taurus. So,
Beth, you might have something interesting to tell me about Taurus.
I do. I have several things. So I wanted to talk first about Alpha Tauri. So the naming conventions of stars in constellations, I think you and Amanda spoke a little bit about it. But so the sort of naming convention to keep things easier is generally the brightest star in a constellation gets given the Alpha designation. But historically, they are also often named.
Yes.
So the brightest star in Taurus is called Aldebaran, which is actually named from the Arabic originally, and it
Okay.
means the follower. And it's called the follower because it appears to follow the Pleiades across the sky.
Yes, it does.
No.
Now, I suppose before we go any further, do you mind just describing what the pattern of stars in Taurus looks like?
Yeah, absolutely. So from here in Australia, it looks like a giraffe
It does.
because it's upside down.
Just the front half of a giraffe.
Yeah. So basically, there's sort of a couple of stars and then a really long neck bit and then 2 long legs coming off in a V, except we're upside down. So that joke, just every time, it's the one time that Australians are actually upside down is when it
upside down
comes to the
in the night
constellations. So the V part that makes the legs of this giraffe are actually the horns of a great bull. And I know that that's a little bit weird if you think about it. You're like, Taurus, a cow, the horns go downwards, don't they? But it's sort of like, it's ancient Greek, and if you think about those ancient Greek pots, the iconic orange and black style pottery,
Yep.
if you think about a bull in that context, like they do often have horns that go quite far up rather than the curly down horns that we might be more used to thinking about.
Right, I see what you mean. Yeah.
Yeah, so that is the V is the horns of the bull, but Aldebaran is part of, it looks like it's part of a cluster of stars that make up the sort of face. And Aldebaran is actually known as the red eye
The
of
red
the bull.
eye of the bull, yes.
Because it is a red giant. It's about 44 times the radius of the sun.
So big star.
Big star.
Yeah, okay, so just to clarify, we've spotted the V-shaped pattern of stars in the sky, which are
Yeah.
the horns.
Yes.
And then sort of slightly offset from the horns is Aldebaran, the red star.
Yeah, it's sort of at the center of the V.
Right.
So it's not like up very far on one horn. It's quite near the center of that V shape, but
Yep.
it is slightly offset. But there's sort of a cluster of stars around there, and that cluster of stars is known as the Hyades. Now, it looks like Aldebaran is part of the Hyades because of where it is in the sky.
Yeah, from
but
a
it's
line of sight.
Yeah, from line of sight, but it's actually about half of the distance that the Hyades are.
Right, so it's not actually part of the Hyades.
It's not part of the Hyades at all. It is just a star chilling out by itself, but it's way closer to us than the Hyades are. So the Hyades are a cluster of stars that's like behind it in the sky.
Gotcha. So this gives me the flashes of, when someone waves at you, like the cute person, and then you wave back, and then you turn around,
waving at the person
and
behind
they're
you.
waving to the group of friends behind you.
Yeah, exactly. So we're waving at the Hyades, and Aldebaran's just in the way.
Yeah, gotcha.
Except it's awesome, and there's something really exciting around Aldebaran.
Oh,
So,
okay.
Aldebaran, the star, is orbited by Aldebaran B, which is a candidate exoplanet.
That I did not know.
Yes, so there is an exoplanet, potentially, we think, around Aldebaran.
Wow.
So an exoplanet is just a planet that's not in our solar system.
Yep.
Some of them are confirmed, some of them aren't. Now, NASA has sent out the Pioneer 10 space probe. Now, the Pioneer 10 space probe is going to make its closest approach to Aldebaran B in about 2 million years.
2 million years.
Yeah.
Excellent.
Yeah.
Now I know Pioneer 10 was not intentionally. It wasn't launched to go to Aldebaran.
No.
It was launched to go to Jupiter.
Yeah, but it's going to get there.
But now that it's flew
Eventually.
past Jupiter, it's now on its just in the direction of Aldebaran.
Yeah. And so maybe in 2 million years, the Pioneer 10 space probe might tell us something cool about Aldebaran B, this planet that's around this star that's in Taurus.
I love the idea.
Yeah.
That's fantastic. I didn't know that Aldebaran had a planet.
Yeah.
Especially because it's a red giant. So stars don't start out 40 times bigger than the sun.
No.
They typically start out about the size of the sun, and then if there are any planets around them, then they. As the star expands, as it gets old, the planets get destroyed as the star is expanding.
Well, I guess there's a possibility, and this is just conjecture at this point, but I guess it's a possibility that a star that large might even be able to steal planets from other solar systems.
Yeah, I guess so. Maybe.
Like, if it's distant.
If it passes close enough.
Yeah, exactly. Yeah, or maybe it's just that the dwarf planets that have previously been around that sun have amalgamated.
Yeah.
But also, I said it's a candidate exoplanet.
Right.
So it's not like 100% confirmed definitely exists. So it might just be because of the way that we find exoplanets is to do with the light of a star being blocked in a regular pattern. It could be something else.
Gotcha.
But it's a very long way away. I'm like, it's half as close as the Hyades. It's still really far away.
There's closer exoplanets than that.
Yeah, Aldebaran is 65 light years away.
65 light years, right. Yeah.
So our information may not be correct.
Okay.
But our best guess at the moment is that there's an exoplanet, and in 2 million years, maybe Pioneer 10 will tell us about it.
Excellent.
If Pioneer 10 is still working in 2 million years.
Now, Taurus, the constellation, is part of the zodiacal group of constellations, which is where the orbits of the planets seem to pass through the night sky.
Yes.
So it's not of any mystical significance. It's just that the planets and the moon seem to pass through that part of the sky. And so as a result, people have been looking at that part of the sky in a bit more detail for centuries. So I imagine Taurus has a lot of stories and histories behind it.
Yeah, absolutely. So like we were saying earlier, Taurus and Orion are often quite closely linked. And it's surprising how much mythology, and I think we've touched on this before, that paints Orion as a man who's going after some ladies. And so the ladies are the Pleiades.
Or the Seven Sisters.
Or the Seven Sisters, or M45.
Yes.
So, yeah, across so many cultures, the Seven Sisters running away from a man is what has been seen in the night sky.
Interesting.
Yeah, and Taurus the bull in several of the Greek stories is getting in the way.
Right.
So is protecting the Seven Sisters, which is especially, I think, poetic, given that the Hyades, which is the star cluster that's in sort of the face of the bull, are actually the daughters of Atlas, which are the sisters of the Hyades, of the Pleiades. So the Pleiades and Hyades are actually...
sisters.
Yeah, the Seven Sisters. There's also the Hesperides and the Hyas in the mythology, but they're not in the sky.
Right.
Yeah.
Wow.
Atlas has many children. But yeah, so the fun thing about the Hyades, they're also known as the rainy ones, and it's partly because of, in the Northern Hemisphere, they're appearing in, or like, when the rains come, but also they're meant to be weeping at the death of their brother, the Hyades.
Oh, wow.
Yes. And they're probably also quite sad because their sisters, the Pleiades, are being chased down by Orion and having to protect them from him.
It's interesting that you say a lot of stories have the Orion being the male after the
Yeah.
Seven Sisters. I think the other part of that I'm familiar with is that a lot of cultures almost unanimously have the Pleiades or the Seven Sisters being siblings of some kind.
Yes,
We often know
seven
them
brothers,
as the Seven Sisters.
seven
but-
sisters.
Yeah.
Or
a
a
hen.
hen. The Danish story is a hen and 6 chicks.
Chicks,
So
yeah.
also siblings.
Yeah, and brothers and things like that. It's just siblings of some kind.
Yeah. So what I quite like about the Pleiades and the Hyades, and again these siblings, and you were talking about the zodiac significance. The Pleiades and the Hyades together actually form the golden gate of the ecliptic. So the ecliptic is the line across the night sky that it appears that the planets and the moon and the sun all kind of follow.
Right,
And that
it's
line
the plane of the solar system.
Yeah, exactly. And the plane of the solar system passes in between the Pleiades and the Hyades.
I had forgotten. I think you told me that ages ago.
Yeah. So it actually, like, within the constellation of Taurus, there's these 2 clusters of stars. So there's the Seven Sisters, which is it's a fairly obvious cluster of 7 stars.
Yes.
And then there's the Hyades, which if you can't find the Hyades, you find the big red one, which is Aldebaran, which is not in the Hyades, but it's in the same part of the sky.
Yep.
And if you watch that part of the sky over the course of a few weeks, you will see the moon and the planets eventually pass through
Yeah.
in between those 2 clusters of stars.
Right, I get it now. It's the gateway of the ecliptic.
Yeah, it's the gateway. Yeah. So yeah, there's I think that's quite beautiful.
Yeah.
And it also makes sense, like you were saying, yeah, people have been looking at this particular constellation for so long. In fact, the earliest depictions of it, one of the earliest that I found is from the Nebra sky disk, which is a northern Germanic Bronze Age, like, piece of archaeology, basically, which is from 1600 BC.
Wow.
So it's thousands of years
Thousands
old.
of years old.
And I think, because you were telling me about cave paintings as well.
Yeah, I've heard about it. There's speculation that some cave paintings from about 15,000 years ago show the patterns of Taurus the bull. I think there's still sort of discussion about, is this Taurus or is this someone's just fanciful artwork?
Yes.
But yeah, there's potentially this human connection to Taurus the bull going back, longer than written language.
Yeah. And I think it's also partly in the Northern Hemisphere, a lot of the significant stars, the most obvious stars as well. The Pleiades is very, very bright and obvious as a group of stars, but it also just happens to be rising as the seasons are changing in a lot of places in Europe.
Yes, that's right.
So that's why a lot of the stars are named, because they will be a sign of a change in behaviour in the people who are looking up at those.
Yes.
So even in Australian Aboriginal cultures, there's stuff like when you see the emu, that means it's time to,
where you hunt the eggs or the emu for the meat or whatever.
Yeah, exactly. And I don't know the exact signs and symbols. That's not the culture that I come from. But, in a lot of the, like, European names for stars will be things like Canis Major is the dog star, partly because of the dog days.
Dog days, yes.
So yeah, there's that cultural connection to the sky.
Yeah, and it really comes back to something you don't really think about until someone tells you, which is that the purpose of a calendar is to keep track of the sky, not the other way around.
Yes.
Yeah, we have to adjust our calendars to match what the universe is doing, whether or not we're paying attention.
Yeah, I mean, well, that's why we have leap years.
Yeah.
Is because, if we were just doing our thing, we would be gradually shifting off and
Out of
off
phase
on
with
those
the seasons,
seasons.
yeah.
Like, we are expecting the seasons to, follow the calendar, but the calendar's really following the
Calendar
seasons.
follows the seasons.
Which is why, as well, when you've got stuff like a Western calendar being imposed on Australia, it doesn't quite make sense. Like, the start of September was meant to be the start of spring, but it didn't really feel like the start of spring. Spring has only really been felt in the last, couple weeks.
Yeah.
But hey, guess what that does align to? The Aboriginal
six
seasons of this
seasons.
area.
Yeah, that's right. And the whole being in tune with the sky and the land.
Yeah. And so the sky and the universe has told people for thousands and thousands of years what they should be doing to survive, and we don't need it anymore to do that for a lot of people, but I enjoy that it still has significance, and I enjoy in a way that we're still continuing that by doing this lovely little monthly show for everyone. It's like we're still looking.
Yeah, please look up, everybody.
Please look up.
Can I tell you the astronomy story you can see written across Taurus?
Yes, please.
You can see the life cycle of a star playing out across Taurus.
That's awesome.
Now, the thing to remember is stars live for billions of years, many of them, so you can't watch a single star over its lifetime, not in our human lifespan. But what you can do is look at lots of different stars at different points of their life, and you start with the Pleiades, the Seven Sisters. They are very young stars. They have just collapsed out of a cloud of gas and dust, and there's actually still residual dust and gas around where the Pleiades are.
Is that why it can kind of look a little bit misty when you look at like the sort of, I don't mean like high-res pictures of the night sky, I mean like high-res space pictures.
Yeah, when you look at the Pleiades out of the corner of your eye, in fact, don't look directly at it, but look out the corner of your eye. That way the light hits the rods of your eye, and they're a bit better at picking up some of this very faint light. And yeah, it does look kind of wispy.
Yeah.
And yeah, some of that is from this sort of residual gas. And also just there's actually more stars there than meets the eye, quite literally. But yeah, these are very young stars, and they're still very tightly bound together by gravity. But over time, as these stars orbit around each other in this sort of mosh pit of star movement, stars get flung out just by chance encounters, and we call this, we say that the cluster evaporates, and the Hyades cluster is in the process of evaporating, and then when these stars get flung out, they then go on and live their normal lives as a star does, much like the sun.
Yes.
And then when these stars reach the end of their lives, they start to swell up and they turn into red giants, like Aldebaran. So yeah, from the Pleiades to Hyades to Aldebaran, you can see the life cycle of a star taking place within a handspan of the night sky.
That's amazing.
It's beautiful.
Now, I think that I would like to turn us to our next segment, because I have a picture that links to Taurus.
Okay, is it time for Space Photo of the Month?
It is time for Space Photo of the Month. Here's my space picture of the month for you, Leon. Please describe what you see.
You know, this is why I like this game, because you never know what you're going to get. And then when you see it, you go, oh, crikey. How am I gonna... Okay. What we're looking at is a race car. Like
a specific kind of race car.
I don't know enough about like car models to tell you what type of car this is, but it is a race car, and it's driving around a dirt track. There's a big wake of dust behind it, so it's an off-road race. However, conveniently, down the bottom of this this picture you've sent me, there's a little tag that says Subaru Impreza WRC.
Yeah.
So yes, it's a Subaru Impreza WRC race car, screaming around the corner of a racetrack, kicking up a huge cloud of dust behind it.
Yeah.
Why have you picked this picture, Beth?
Because Subaru.
Oh, I know why, but you better tell us.
Because Subaru, the logo of Subaru, what's it made of?
1, 2, 3, 4, 5, 6 little star-shaped patterns on the side of this car.
Because guess how many of the Pleiades you can see from Japan?
6 of them.
You can, and Japan call the Pleiades Subaru.
So we call them the Seven Sisters, but I've noticed that myself. When you look at them, you really only can see 6.
Yeah.
And it's called Subaru in Japan.
Yeah, that star cluster. So this is a Subaru Impreza, which is a rally car.
There you go.
It is connected to space, because this car is one of the most iconic cars that Subaru make, and it is the symbol of the Pleiades.
It is. There you go. So it's not like inspired by it. It is literally named after.
It's then named after the constellation. And I just picked this particular picture because even though there are many different brands of Subaru, the Impreza, the rally car, just seemed most fun to describe.
When you can pick an exciting race car picture.
Yeah.
Beautiful.
So there you go.
Well, thank you for sharing that. I'm sure some people have just learnt the origin of the word Subaru.
Yeah, exactly. And so maybe your life is more connected to space than you thought if you drive a Subaru.
I think so.
You drive a space car.
Yeah. All right.
What picture do you have for me, Leon? And is it actually slightly more space relevant than...
I will send you this picture now.
oh, this is related to space, and I can tell. So there's a person. There's a person who has long hair, but the hair is waving around as if it is underwater, which makes me think that they are on the International Space Station.
You are correct.
So I think I'm looking at a view from the International Space Station, because the background is very busy and very industrial looking, with all of the white, with all of the knobs and buttons and handles that you would expect. And then they are at a Velcro table. So there's a table with lots of pieces of Velcro all over it, because if you don't Velcro things down in space, they go flying.
Yes.
What's quite fun is there is some... There are some like branded foods here, but they've blocked out the brands, and I don't know if that's a NASA thing or not, because there's some iconic ketchup there, but the logo is definitely obscured. And then the central part of the photo, so there's this astronaut who is wearing an eye patch with a pirate symbol drawn on it. They're wearing a US Navy t-shirt, I think. And in front of them is what looks like pancakes, I think. 2 stacks of pancakes covered in what appeared to be some sort of strawberry syrup and cream. And happy the da.
Which might be happy birthday.
Maybe. What's going on here, Leon?
So you're correct. This photo is taken from the International Space Station. And yes, that is the astronaut Sunita Williams, who is on there right now. Now, you may remember we've spoken about Sunita, or Suni, a few times now.
Yes.
She went up on the troubled Boeing Starliner and was supposed to be back on Earth months ago, but is still on the International Space Station, having a great time.
Oh, boing.
And in fact, her mission, because it has been extended, has now included her birthday. So she celebrated her birthday on the International Space Station, and it happens to be on the same day as International Talk Like a Pirate Day.
Oh my goodness, that's amazing.
Which is why she's wearing an eye patch and something of a bandana to roughly hold her hair in position. And yes, it's just the most wholesome picture of this astronaut who, astronauts they're not there to have
they're
have
at
fun.
work.
They're at work many hours a day, and so. But yes, at the same time, they've found the time to take this charming little photo of Suni having her birthday, wearing a pirate patch, and
with her pancakes.
Yeah, with pancakes, and it's just imagine if it's just the perfect combo of all the silliest things you can have.
And also, can you imagine how cool it is to have your birthday in space?
In space, that's right.
I still think it's awesome that we can take a photo of a person in space. Like, if I sit back and think about that sometimes, I just within the last 100 years, this has happened.
Yeah.
Like, we've got someone in space. I just think it's really awesome that we've got a photo of someone in space, let alone a person whose birthday it is in space. That's awesome.
Yeah, it's brilliant. So yes, there you go. And yeah, you're right. There is some judicious choice of application of labels over the food products on the counter there. Every single thing that goes up has a barcode on it, and the barcodes have been placed over the labels.
Yeah, I don't know how intentional that is.
Yeah, I'm not sure. But
whether it's just obscuring branding or whether it's just so that you've barcoded right next to where it says ketchup so you know what it is.
So you know what it is.
All right. So I think that brings us to the end of Space Photo of the Month. But again, segue, because how did people get to the ISS? How did Suni get there? On a space flight. What are we doing next, Leon?
It's Space Flight Focus.
Yay!
2, 1. We have a liftoff.
Nice segue, Beth.
Thank you, Leon. So, what spaceflight are we chatting about this month?
This month is all about the Europa Clipper.
Ooh.
The Europa Clipper is something many people have been looking forward to for a very long time.
Now, I don't know much about the Europa Clipper, so I am all ears, and I'm going to be asking you all of the questions.
Yes. Well, I'll tell you the straight to the point. So the Europa Clipper is a NASA spacecraft. It's a robotic spacecraft. And
no people.
And it is launching on the 10th of October. So
that's soon.
It's very soon, as of this recording.
Yeah, it might even be in the past for some people listening to it.
It may be, yes. And it's on its way to Jupiter to study one of Jupiter's moons called Europa.
Yes.
Yes. And you know about Europa. Beth, tell me a bit about Europa.
As in the moon?
The moon, yes.
So the moon Europa is icy.
Yes.
Which is exciting because ice comes from water.
This is high-level stuff.
Yes. But water is what is required for life on
Yes.
Earth as we know it. If you wanted to know about, when I said Europa, the moon, I'm clarifying because there's Europa, the mythical character, who is consort of Zeus,
Yes.
as you may describe.
Yes.
Zeus is one of Zeus's many lovers. She was the one that had a bit of fun where Zeus was in the form of a bull and abducted her.
Yes, and in some cases providing the origin story for Taurus.
Yeah.
But
But yeah, she was a Phoenician princess. She was the mother of King Minos as well.
Yes.
And King Minos is famous for being the king who made a labyrinth
With
and
the
trapped the
Minotaur.
Minotaur, who is also a bull-headed. So it's all about bulls this month.
It is, isn't it? And yes, when it comes to Europa, the moon,
Yes.
there's the sort of mantra that people follow is water, chemistry, and energy. And that's what you sort of need for life. You know,
Yes.
the origins of life are still an ongoing thing, but here on Earth we have it. We have water, we have active chemistry, lots of complex molecules, and we have an energy source, the sun.
Yep.
Now, Europa, it seems to potentially have all of those things, but we need a closer look, and that's what the Europa Clipper is going to do. So,
Oh, wait, is the Europa Clipper the one that's basically going to go out and it's got like nets and it's just going to try and catch? Or is that something else that I'm thinking of?
that's definitely something else.
Oh, never mind then. Never mind.
However, we will come back to it. It's going to try and catch some things. But yes, it's going to launch on the 10th of October. It's going to spend 6 years flying to Jupiter.
6
6 years, I know.
That's why there's no people on it.
That's why there's no people on it. Yes, that's right. And it's going to orbit, interestingly, it's going to actually orbit Jupiter, not the moon Europa itself.
Okay.
Just because of the way gravity works and how much fuel it has on board. But it's going to orbit Jupiter in such a way that it's when it's far away from Jupiter, its apogee, as it's called,
Oh, wow.
takes it past Europa. So, that orbit is going to be designed to swing past Europa every time it goes away.
Right.
And during that, it'll be pointing all of its science instruments at the moon Europa and, learning more about it.
Is it going to be doing something else while it's not near Europa?
It'll be transmitting its data back to Earth, obviously. When it's right near Jupiter, it'll probably be turtling up. Jupiter's quite not a nice place to be near.
Right.
But you can still see them. You can see Europa from Earth, so
Yes.
it'll still be studying Europa from a distance. But
Okay.
then it'll also have these really, really close flybys where it'll get the best data, so to speak.
Right.
But yeah, the bit that started it all is Europa's composition of ice. It's sort of known that Europa it's about the size of Earth's moon. So it's only slightly smaller than Earth's moon, which is
So
about the
which
size
is
of
about-
Australia, by the way.
Yeah, isn't the moon something like a third of the size of planet Earth by volume?
A quarter by diameter.
A quarter by diameter.
Yeah, so
I can't do
the
that
size of
maths
Australia.
in my head.
so it's the size of Australia. That's how I like to think about it. So from Perth to Sydney, that's the size of the moon, and then slightly closer is the size of Europa.
Cool.
And yeah, it's been known since the 60s that Europa is covered in water ice.
Water ice, to clarify as well, because once you get far enough away from the sun, you can make other substances solid. So like
Right.
surface of
Nitrogen
Pluto
ice.
has nitrogen ice. So
Yeah.
yeah.
Or Mars's atmosphere freezes out into carbon dioxide ice, also called dry ice.
yeah, exactly. So yeah, if you've ever played around with dry ice, that is dangerous, and you shouldn't do that without proper supervision. But also, yeah. So to clarify, water ice.
Yes.
So H2O but
H2O,
solid.
But solid. But the bit that's really the intriguing is that the surface of Europa, this water icy surface, it shows two very interesting things. One is that it shows lots and lots of cracks. Almost like it's moving around. If you think about Earth's surface, where the
Yes.
rocky surface is cracked up into what we call tectonic plates.
Yeah,
that are
moving
kind of
around on
moving
the
around.
magma.
Yeah. And so this icy surface of Europa is also cracked, suggesting that it might be moving around.
Like ice flows in the Arctic.
Yes, exactly right. But of course, to move around, you need some sort of active geology going on. It doesn't just
Would that count as chemistry and energy, maybe?
maybe. Well, we'll keep digging, shall we?
Oh.
But the other interesting thing is that it shows relatively few craters. Think about the moon. How many craters are on the moon?
So many craters.
So many, yeah.
So many.
But that's because the moon doesn't have active geology to reshape its surface. Like here on Earth, if the Earth gets hit by an asteroid, we have weather, we have wind, we have rain. It
Yeah.
washes away craters over time.
Yeah.
You have active things happening.
Yeah.
The moon doesn't. It doesn't have any of that. So when a crater forms on the moon, it stays there forever.
Yeah, which is why we've still got the footprints on the moon of the Apollo astronauts as well.
100%
stuff
right.
like that.
Yeah, there's no breeze to blow them away.
Yeah.
Whereas on Europa, there's almost no craters. So there's nothing. It suggests that the surface is very new, which means it's active. Things are, recycling the
Something's
surface.
happening
Something's
there.
happening, I know.
What's happening?
Yes.
We don't know. That's why we're sending the Clipper.
Yeah, that's right. Now, the Clipper's not the first spacecraft to ever actually go to Jupiter. There have been a few. In fact, there's one.
Juice?
Yeah, there's Juice that's on its way right now. Juice we spoke about in a podcast about a year ago.
Yeah.
It's on its way from the European Space Agency. It's not there yet, but it's on its way.
I mean, if it takes 6 years to get there, then...
Yeah, that's right. But in the late 90s, there was a spacecraft called Galileo that orbited Jupiter, and it did have some problems. Its antenna didn't deploy. Not its antenna. Its
Sensors?
Antenna. Yeah. Its antenna to communicate with Earth. So it could only communicate a limited amount of information.
Right, so its comms didn't work properly.
Yeah, exactly. But it did do a few flybys of Europa, and here's what's really exciting is that by studying, here's what's really cool. When it sends a signal back to Earth...
So this is Galileo.
Galileo.
Yeah.
It's at a certain frequency, 100 megahertz or something like that. But as it flew past Europa's gravity drags the spacecraft along a bit, and it speeds it up, and that causes a bit of a Doppler shift in the frequency of the communication.
Is that blue shift?
Depending on the direction, could be red shift or blue shift.
Yeah.
But it's the same, the ambulance driving past you. Yeah. And by listening to how Galileo's frequency signal changed as it flew past Europa, they could actually use that information to model the distribution of mass in Europa.
I love nerds. Like, I am one. I love it when people can work out stuff like that. Like, isn't that just incredible?
It is incredible. And what they found is the best mathematical model to fit this signal from Galileo was that the icy surface of Europa was about 100 kilometres thick, and of which maybe the top 25 kilometres was ice, and the next 75 kilometres was probably liquid water.
Like a massive ocean
Like
the
an
size
ocean.
of the moon.
Yeah, 75 kilometres deep of water. Yeah.
So what I'm reading from this, 75 kilometres deep, I know that the depths of our ocean, where we've got that tectonic activity, it breaks through the crust into the ocean, and actually in that deep ocean, we around where that heat is, at least from those like tectonic plates and that tectonic action, you end up with these hot water flumes which are surrounded with life.
Yes. Yeah. Now let's be clear. This is what we've observed on Earth, and this is what we suspect there's this ocean on Europa,
Which is why we're sending people.
That's right. We can't sit here and say that this is there's life on Europa yet.
No.
But there's the thing.
I mean, there might be.
The best model of Europa is this 75 kilometre deep ocean, which is more water than all of Earth put together. Even though Europa is smaller than Earth,
because it's all ocean.
Yeah, when you cover it in 75 kilometres of water,
Yeah.
you've got more water.
How
than
deep
Earth.
because our ocean is
About 11 at the deepest.
Yeah.
11k. So yeah, it's about 6-7 times deper than Earth's oceans.
And we get some weird fish down there.
Yeah.
Can you
some
imagine how weird
stuff.
the fish would be on Europa?
Yeah. So yeah. Now, what's interesting is that the energy source for Europa is a lot different to here on Earth.
Yes.
So here on Earth, we get our energy on the surface from the sun, and energy from deep down on the bottom of the ocean, as you said, is from the tectonic plates moving around.
Yeah, and the heat from
the core.
Yeah.
Now, we don't know necessarily if Europa has tectonic plates moving around, anything like that. What we do know, however, is that Europa's orbit around Jupiter is not perfectly circular.
Oh.
And that does make a difference, because sometimes Europa is slightly closer to Jupiter and sometimes it's slightly further away. And what that means is when it's closer to Jupiter, Jupiter pulls on Europa harder and it squeezes it out, almost like an AFL football. It becomes sort of egg-shaped.
Oh.
And then when it moves further away, it becomes more shaped like an orange. And then it goes from football to orange to football to orange every orbit.
Whoa. If the gravity is strong enough to do that to a planet, what would that do to life on that planet?
Well, what it does is now, to be fair, I'm
Not planet,
severely
sorry, moon,
exaggerating
moon,
this.
moon.
Yeah, I'm really, it doesn't stretch out to that aspect ratio, but, by a good maybe kilometre or something like that.
That's a lot.
Yeah, and what it does is, if you've ever bent a paperclip back and forth, what happens?
Yes, you end up with weakness.
weaknesses, but that weakness manifests in the form of heat.
It does.
And so this is where we think the energy from Europa comes from, is actually this flexing caused by Jupiter, and it melts the moon from the inside out, which is why the oceans are at the bottom, not at the top.
Oh, yeah, because the heat of the sun's not doing
It's too far from
anything
the sun
out
to do
there.
anything out there, yeah.
So the internal heat from the flexing of the core of the moon
Yes, is
is,
likely what's melted the oceans from the bottom up on Europa.
oh my goodness.
Yeah.
Yeah. Does it have an atmosphere then?
Well, it has a very minimal atmosphere. And funny you should ask that, and your comment before about a satellite that's going to go catch things. One of the objectives of the Clipper is to get really, really close to Europa, a couple of 100 kilometres, and just scoop up whatever it can out of the minimal particle environment around Europa. And that material is expected to be stuff that's been blasted off the surface. So by analysing that, they'll be able to learn what the surface of this ice is made of, as in what organic chemistry it has going on inside.
Because
like
water, even though we know water is H2O, like if you get a cup of seawater, it's not just going to be H2O. There's going to be impurities in it. There's
That's
going to
right.
be plankton. There's going to be
all sorts of things.
Yeah.
So that's one of the things they're going to be looking for. So Europa is this fascinating world that has water.
You're telling me this now, Leon, and I've got to wait 6 years until it even gets there?
That's right. It has an energy source from Jupiter's flexing it, and then if we suspect that after this 100 kilometres of ocean, then there's this rocky object.
Yeah.
And that's going to dissolve. The water is going to dissolve minerals out of the rocks and make a saltwater ocean.
Yeah.
You've probably got chemistry going on there. Water, energy, and chemistry. Those are the three things that's the mantra that NASA's going by, and Europa seems to have all of them. And this is why they are very, very excited. Lots of people are very excited by the Europa Clipper launching in a week.
So so JUICE is already on its way there.
Yes.
Is JUICE doing something similar?
Yes. So JUICE, for those new to it, is a European Space Agency spacecraft.
Jupiter's Icy Moon Expedition? Explorer.
Yes. And launched last year. And it's going to be doing something similar. It's going to be orbiting Jupiter as well and studying its moons. But it's going to be focusing most of its attention on Ganymede,
which
is the largest moon of Jupiter, which is also strongly suspected to have a subsurface ocean.
Yes, because it's an icy moon. And it's
explorer.
A water icy moon.
Yes.
Yeah.
But Ganymede's surface is actually covered in rocky material. So that subsurface ocean it's a little bit less obvious than Europa.
Okay.
But it will also be studying Europa too. And the two will complement each other.
Yes.
Yeah. The Europa Clipper, 100% focused on Europa, and JUICE is a little bit of everything, but mostly Ganymede.
Right.
And it will eventually orbit Ganymede if all goes well.
Yeah. That's so exciting.
Yes, it's very, very cool.
I can't believe I have to wait 6 years for the results of this.
Yes.
Well, hopefully the mission goes well and the launch goes well. Hopefully we're not revisiting the Clipper in next month's spaceflight fails.
No. Look, it's launching on a Falcon Heavy, so the legendarily reliable Falcon 9.
Okay.
And the Falcon 9 hasn't had a launch failure for 5 years now.
Touch wood.
Like that. Yeah, it had a landing failure last month, but that was like a landing leg broke. It wasn't even a problem with the launch.
Right.
Yeah.
So fingers crossed for the Europa Clipper.
Yeah, there's a couple of other interesting things I'd like to quickly mention.
Yeah.
There is some evidence of geysers on Europa.
I think this was where I was getting the net idea from.
Like to fly down through when a geyser goes off and scoop up material from.
Yeah. I think that I may have gotten...
Cassini did that at Enceladus.
That would be what I'm getting all mixed up in my head then.
Yeah, exactly. So Cassini, spacecraft around Saturn. Enceladus, icy moon around Saturn. Geysers, water volcanoes, basically.
Water volcanoes.
Yeah, here on Earth where we have molten rock that spews up from the solid ground and makes volcanoes. Same thing, just replace it with ice and water.
Or in Iceland, where you do get geysers.
Yeah, where you do get geysers. And
Yellowstone.
Yellowstone, all sorts of places,
water spewing up into the atmosphere, but obviously in Europa we're talking about maybe a bigger scale than...
Well, yeah, because Europa has less gravity.
Yeah,
these
the water could get
volcanoes
further
would be
up.
hundreds of kilometres tall, which would be pretty awesome. Yeah. So there seems to be this evidence that as I said, the icy surface might be about 25 kilometres thick, but there may be these weak points where it's a lot thinner, and you can get these eruptions happening. So if you wanted to get down to that ocean, that in a future mission 60 years from now, that might be where you try and drill through.
Yeah.
Very cool.
What was the other? Was there another last thing that you wanted to say about
There
the Clipper mission?
was, which is that one of the other pieces of evidence for this ocean was the way Europa's magnetic field works, which is that it doesn't actually have a permanent magnetic field. What it does do, however, is that Jupiter has a very strong permanent magnetic field, and Jupiter spins every 10 hours. And so from Europa's point of view, they see this magnetic field of Jupiter flip from north to south every 10 hours.
Wow.
And what it does is that changing of the magnetic field induces its own field inside Europa, and it pushes back against the Jupiter magnetic field.
Okay.
And by modelling the size of, by looking at the strength of that field, you can determine that Europa, in order to even be able to produce a field of that strength, that water must be salty. Yeah, it wouldn't happen in fresh water. It must be a saltwater ocean, which leads to, because salt water has to conduct electricity to produce that magnetic field. And that's why they're thinking that's another piece of evidence for this chemistry. There are minerals in the ocean of this moon. It's not just fresh water. Very cool.
That's so
and
cool.
all of that from measuring a magnetic field.
Wow.
Theoretical physics. It's the best.
Oh, that's awesome.
Now, I could go on and on, but we'd better not.
We better not. We have one more segment to get through, and I don't have a decent segue for this one.
Deep Sky Dictionary.
Deep Sky Dictionary.
I am not sure I know how to answer that.
I like that one. This is good. So our Deep Sky Dictionary for this month is controversial.
Ooh.
I know. The word is planet. You might not think this is a controversial term.
Oh, dear.
Maybe we should do moon next month.
No, that'll be worse.
We'd have to do a whole episode just on moon. So I'm going to go for the Google, other search engines are available, definition. Noun, planet.
Yes,
A celestial body. We've done celestial.
we have.
Moving in an elliptical orbit
We've done
around
elliptical.
a star.
Wow.
I don't think we did elliptical. We did eccentric.
Oh, we did eccentric. Yes, we did.
But
Sorry.
elliptical just
It means
just
eccentric.
oval shape.
Yeah.
Archaic astrology definition: a celestial body distinguished from the fixed stars by having an apparent motion of its own, including the moon and sun, especially with reference to its supposed influence on people and events.
Right.
There's the astrology bit. But where it comes from, because we all know how much Beth loves etymology and entomology, but in this case etymology.
Yeah, is this the Wandering Stars, is it?
Yes, so planet is actually Middle English, is when it first appeared in our... So it's quite an old English word. From the Old French planet, which is planet with an E on the end, from Latin planeta, from Greek planetes,
Yes,
which
that's the one I'm
means
familiar with.
wanderer.
Wanderer.
Well, from Older Greek planan, wanderer.
Right.
So, yeah.
Yeah, so this
Old
would come
word.
from... Yeah, night after night you would look at the stars, and the stars, they are moving, but they're so far away you can't tell.
Yes.
However, the planets are much closer, and even though some of them take years to noticeably move, you
Yes.
still see them move compared to the background stars.
Yeah. I've got a link. I've got a link back.
Yeah.
Because eventually those planets appear to move between the Pleiades and the Hyades along the ecliptic.
Oh, beautiful. Yeah, they move along the ecliptic. Wandering stars.
Yeah. So, where's this?
That's
where's
not the
this,
controversy.
That's not the the sort of like English language definition of the word planet, not controversial. The space definition of the word planet, I'm going to leave to Leon.
Yeah, thanks, Beth.
So, well, okay. The reason that this gets controversial, I feel, is partly to do with Pluto.
Yes, like and
Which was
subscribe if you think Pluto's a
my
planet.
favourite planet growing up, and then they unplaneted it.
Yes, they
Although
did.
they didn't fully unplanet it because it's a dwarf planet, so
Yeah,
it's still
that's
got it's a small wanderer across space.
Yep. Yeah, it's interesting. It came down to the sort of explosion of knowledge that happened in the sort of early 2000s and is still ongoing in the study of the outer solar system around our sun. And because, that's right, up until like 1991 or thereabouts, 1990 maybe, I think, we knew of there were nine big things in our solar system.
Yeah.
The 8 planets we now have and Pluto. And then about 1990, they found something else beyond Pluto. And it was small and unremarkable, and it was kind of forgotten about. But then soon thereafter, in the early 2000s, we found an object which we now call Eris.
Yes.
And
named after the goddess of chaos.
Yes. Yeah.
Sorry. Caused chaos.
Caused chaos, yeah. Eris is actually heavier than Pluto. It's not
Right.
bigger than Pluto, like size-wise, but it is
it's
heavier.
denser.
And when it comes to space, gravity is what matters.
Yes, and gravity is reliant on mass, so heavier matters.
Heavier matters. And so... And this is why the moon goes around the Earth, because the moon is the Earth is 80 times heavier than the moon. It wears the pants. It dominates our system. So if Eris is heavier than Pluto, if you're going to call Pluto a planet, you'd have to call Eris a planet too. And then the problem is we started finding more and more of these objects.
Haumea.
Haumea.
Maki. Sedna, eventually.
Sedna's out there. And Eris is the only one that we know is heavier than Pluto, but... suddenly we realised we had to start drawing a line somewhere.
Well, I guess because either, one that we know is heavier than Pluto, so do we... the question, as far as I understand, then became do we add a 10th planet, or do we have to add 10 more planets? Do we have 19 planets? Where do we draw the line?
Yeah, imagine sitting down to your space test and naming all 80,000 planets in the solar system.
And because we had this heavier dwarf planet, or this heavier object out there near Pluto in the same kind of space that Pluto was, even if we drew the line at Pluto, we would definitely have to include a 10th planet.
Yes.
We would have to include Eris.
And then
I think we should have done, but that's fine.
Yeah, but then it becomes, this arbitrary, anything heavier than this that does that. So instead, the astronomers all got together and came up with a new set of rules. Which is
Pluto's too small.
Well, yeah, those
just
3
to spite
rules,
you, Beth.
Yeah, pretty much. But they are still themselves a bit controversial. The first 2 are pretty okay in my opinion. First one is a planet has to be round, and that makes sense. So that
is Pluto round?
It is, yes.
Pluto is round.
There's a fancy terminology, actually. It's called hydrostatic equilibrium, which means that...
That's a different Deep Sky Dictionary.
it has to have enough gravity to pull itself into a round shape.
Right.
So if you look at some of the weird moons of Saturn, they're oblong.
Mars
is potato moons.
Phobos and Deimos are potato shaped. Yeah. They're not big enough to make themselves round.
Yeah. So, that's right. And, depending on what the moon's made of, you need a certain amount of gravity before it will become round. So that makes sense. The second obvious one is it needs to go around the sun. So that rules out things like Earth's moons. Yeah. Oh, Earth's moon, sorry. They're not planets because they don't. Yes, I know the Earth then goes around the sun and so on. But no, its primary parent, its first parent is the Earth.
Yes. So if you're imagining the point in space that it goes around in its local circle.
Yeah, that has to be the sun.
The sun
to be a planet.
Yeah, and then not our sun, but it has to orbit its sun.
Yes. Well, I was about to say. Then there's this little caveat of what about planets around other stars, and you go, all right, it has to go around a star.
Yeah.
But there are some troubles with this definition actually as well. But the third one is the most controversial, which is that a planet has to have cleared its orbit, and that's already deliberately vague. What they're kind of implying is that the planet has to have had enough gravity so that if there's something else in the way, the planet's gravity will have slungshot that object out of the way.
But then what about a moon?
What about a moon? And what about things that are co-orbital? Like if there was something on the other side of the sun from Earth.
Going around at the same time but opposite.
Rate. Yeah, exactly. Yeah. Things like that.
Because technically that third definition would then mean that... Because that would be possible because the gravities of those planets wouldn't be affecting each other
there's
too
some
much.
Weird stuff going on with Lagrange points and whatever, but long story short, it's a bit tricky. But basically what it does is it rules Pluto out because Pluto doesn't have enough mass to clear out the orbit, because what we've since discovered, as we know, is what we now call the Kuiper belt. There's hundreds of objects, most of them smaller than Pluto, or all of them smaller than Pluto, but they all share roughly similar orbits around there.
Right.
But Pluto doesn't have enough gravity to fling them out of the way. If you put Jupiter,
pull them in to make it to make a moon.
Yeah, if you put Jupiter where Pluto is, Jupiter has enough gravity to pull in everything out there.
Jupiter had enough gravity to pull in Saturn.
Yes, exactly. So Jupiter would be totally comfortable out where Pluto is.
Right.
But Pluto, because as you get further from the sun, the distances get bigger. So Pluto never gets close enough to any of these objects to clear them out of the way. And as a result, it hasn't. And as a result, that third caveat is what disqualifies it from being a planet.
Isn't there also debate about whether Pluto's moon is Pluto's moon or whether Pluto's moon is a binary planetary system?
Yeah. And
so Pluto's moon,
its largest moon.
Pluto's largest moon,
Yeah.
Charon.
Yeah, or Charon.
Charon.
Or Shazza.
Shaz. Also, again, sorry, Beth sidebar for how beautiful this is. Pluto is the ferryman to the underworld, and Pluto is the god of the underworld, and Charon is the ferryman of the underworld, so it's the one that brings the dead souls. But Charon in space is half the size of Pluto.
Yes.
But isn't there something about their gravitational midpoint, their barycenter?
Their barycenter, yeah, their center of mass.
Yeah. So they basically, the center of mass of both of them is outside of both of them.
Yeah.
So the moon has a gravitational effect on the Earth.
Yeah. So Earth's moon.
Earth's moon has a gravitational effect on the Earth. We see that in our tides and oceans. So the moon is orbiting the Earth, but the center of the moon's orbit probably isn't actually the very center of planet Earth. It's slightly outside of the center of Earth, but it's still under the surface of the planet.
Inside the planet.
It's still inside the planet because, the Earth is pulling on the moon, but the moon is pulling back.
Yeah.
Whereas with Charon and Pluto, that point is not inside the surface of Pluto.
That's right. It's outside, yeah.
It's outside the surface of Pluto.
So, yeah, the way I think about it is like a dumbbell spinning around its midpoint.
Yes.
Or it's slightly off midpoint, but yeah.
Yeah.
Yeah, you're right, yeah. They don't so much orbit, Charon doesn't so much orbit Pluto as so much
they orbit each other.
Yeah.
Which is,
Yeah, and so this is my personal thoughts. I think the definition at the moment is at a crossroads. I think the definition that was come up with in 2006 that disqualified Pluto was an attempt at the time to put what we knew about the Kuiper Belt and beyond into the terminology we had. But, the knowledge and how many other things we know about since it's only been not even 20 years, it's only been 18 years. But since then, we've learned so much more about what goes on out there and how many more objects are out there. I think the definition will change again eventually. Astronomers will have another convention and say, here's what we now understand about what's going on in the outer solar system. And, that definition will be updated again, possibly to include Pluto, possibly not.
I hope it includes Pluto. I hope it includes Eris. I think the goddess of chaos deserves to be in the solar system.
I'm ambivalent either way. I just think that people, the ones I find people who are most passionately arguing for Pluto to become a planet are just nostalgic.
Yes.
But when you really look at what's going on in there and how Neptune actually influences Pluto's orbit and all these other objects out there, there's a lot more going on than just, I really liked it as a kid, so it needs to be a planet.
Yeah, no, that is true. I think the really important thing, though, that I get a lot, I know, working in the planetarium, is we say the way that it's often communicated, not by us, but by other people, is, Pluto's a dwarf planet now because it's too small.
Yeah.
And that makes people think that Pluto shrunk in 2006, which is why it's now a dwarf planet.
Yeah.
Because we're like, Pluto was a planet, but now in 2006 it's called a dwarf planet. People are like, a fairly logical leap that it shrunk, it got smaller.
Or it's just too small. It is actually big enough. It's in hydrostatic equilibrium.
Yeah. So, Pluto's not too small to be a planet. It's just that we discovered more Pluto-sized stuff in the Pluto place.
The word dwarf is doing a bit too much lifting in that dwarf planet phrase.
Yeah, for people's conventional understandings of things. And, that's the thing, is that if you're talking about the umbrella of planet within just the English language, Pluto's a planet, but it's not a planet.
Yeah. Yes, that's right. My two thoughts on this are, I think the future definition of a planet, whenever that may come, will probably be something about what you spoke about, where if the planet has any moons, is the center of gravity inside the object or outside of it?
Right.
I think that would be a logical thing to include.
Yeah.
Because, the other thing that comes out of this is we have discovered a lot of other what are called binary systems.
Yes.
And that's, Pluto's probably what will eventually be called a binary planet.
Well, because we have binary star systems where there are two stars that orbit a central point between each other. So if you can have binary stars, why can you not have binary planets?
Yeah, and you can have binary asteroids as well that we know about.
There you go.
So there's that definitely. But the other thing, and here's my challenge to anybody who's sitting here saying, no, Pluto's a planet and I don't care what the smarty pants say. My challenge is take Pluto, which is about the size of South Australia. So it's, a third the size of Earth's moon. And it's made of like rock and water and nitrogen and ice, and it's solid.
Yep.
Now, put that in one hand.
Okay.
Now take Jupiter, which is 12 whole Earths from side to side, and that's made of gas.
I don't think I can hold that in my hand.
Put that in the other hand. It's made of gas and weighs about 1% the mass of the sun.
Yeah.
And now tell me why those two are the same thing.
Yeah.
And that's my challenge. Not that I am trying to be a smartass, but this is why trying to classify what a planet is so hard.
But
because if you try and put those in the same box, you suddenly realise how different they are.
But I have a riposte for you then, Leon.
Oh, yes.
But if I'm comparing Earth with Pluto and Jupiter, I would say that Earth is more similar to Pluto than it is to Jupiter.
Yeah, that's right. So
there we go.
Don't know.
We've left you with an armchair quandary.
Well, if you put Earth where Pluto is, Earth would not have enough gravity to clear out its orbit.
Oh.
So that
is Earth a planet?
And this is why that definition is so controversial, because it doesn't just classify a planet based on what it is, but based on where it is. And that's upset a lot of people, which also brings me back to one other thing where we mentioned planets around other stars. We have found planets that are just free floating in space, rogue planets as they're called. So, what do you even make of those?
Oh my goodness. Well, I think we've left the listeners on a quandary.
Yes, I wish we could say tune in next month for the answers, but
we don't have
them.
We can make them up,
does,
but no one's got the answers yet.
Oh dear, I think that's probably a good place to leave it, Beth.
Thank you so much for having me, Leon.
Thanks for being here. It's been a time and a half, and thank you everybody for listening. We'll see you next month where we talk about the night sky and the space news for November. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.